Hello. Today we're going to start a new unit talking about waves. And so to begin, we'll talk about some of the basic quantities and qualities of a wave. First of all, a definition. A wave is some sort of a disturbance that carries energy through a material or matter or perhaps just empty space. Think of a lake, for instance, and you were to drop in or throw into it a rock. That disturbance causes waves that go out and out and out and spread that disturbance out to the edges of the lake. That would be an example of a water wave. Now, waves are actually all around us. We've seen water waves, but you also hear waves all the time. The sound particles that are made are when your speakers kind of move and wiggle around a little bit. They disturb the air, and that disturbance is carried from molecule to molecule, and molecule kind of spread out until it reaches your ear, and your ear interprets that as different sounds with different volumes and different pitches and so on. Your eyes are tuned to notice light waves, but the light is actually just one small part of a much bigger, broader spectrum of waves, which include radio waves and microwaves and X-rays and things like that. A string, a guitar string, for instance, or musical instruments have strings that carry disturbances across them. Earthquakes involve wave theory that shows up in lots of different places. So there are lots of different characteristics of waves worth talking about, and most of these will be individual videos, but I want to talk about a few of them specifically today. We'll focus in on the medium of a wave. The medium of a wave is the material that the wave goes through. A type of wave, there are primarily two different types of waves, longitudinal waves and transverse waves. And we'll talk about both of those, and I'll show you some examples of each of those. The shape of the wave, something we probably won't get into a whole lot in high school, but most of the waves that we'll look at will be nice, smooth, sine curve sort of waves, just kind of go up and down. But you could have what are called square waves or sawtoothed waves and things like that. They all have different properties that are worth studying. Amplitude, just kind of a brief introduction. Amplitude is kind of the bigness, the sizeness, the height of the wave if it's a water wave, the volume if it's a sound wave, and the brightness of something if it's some sort of a light wave that we can see. Wave speeds, how fast it travels through that material. Wave length is the length from one spot to the next corresponding spot in a wave. And frequency is how often these waves occur. When you're standing in one spot, how many times does a wave pass by you? So all those we'll dive into in more detail in a second. Types of waves. A transverse wave is probably what you've seen the most. A transverse wave is like a water wave where the actual particles of water just move up and back down again. I guess sometimes they move in a little bit of a circle, but the water waves themselves don't transfer across the ocean as the waves push it. They move up and down while the wave, the disturbance moves horizontally. If you've ever been to a baseball game and you've done the wave, you've been a part of a transverse wave where the particles, you, the people, move up and down, but to an observer, it looks like that disturbance moves left to right across the stadium. So a rope will do this too. You swing a rope from side to side like a jump rope. You'll see that the individual strands move left and right, but the wave itself seems to move down the rope. So electromagnetic waves are an example of transverse waves. Here's a kind of a picture of one, if you can see it. What moves is a disturbance of an electric field, shown here in the blue. And associated with every change in electric field is a change in a magnetic field that's at a right angle to that. And those disturbances make their way through air or through water or through empty space at times. So that's an electromagnetic wave, an example of a transverse wave. Now, the other types of waves that we can study are called longitudinal waves. Now, longitudinal waves are waves you haven't probably seen too often. I don't have a video of myself doing this, but a demo I like to do in class is to get out a Slinky, and if I kind of bunch together a couple strands of the Slinky and then let go, you'll see that that chunk of tightly close together pieces of Slinky moves left and right down the wave. And so that's an example of a longitudinal wave. In that example, the particles move left and right as the wave also moves left and right. If you were to think of maybe a bunch of cars, all kind of big traffic jam, car right after another, after another, after another, after another, and all of a sudden the car in the back gets rear-ended, that car would bump the car in front of it, and it would bump the car in front of it, and it would bump the car in front of it, and that disturbance would move through all the cars. That'd be an example of a longitudinal wave. And a lot of different waves exhibit that property as well. Sound waves, probably the most common. When I make a sound, I disturb the air. That air molecule disturbs the air molecule next to it, and it disturbs the air molecule next to it, and so forth, and it just pushes the wave all the way until the disturbance reaches your ear. So that's an example of a longitudinal wave. Thanks for watching. In our next video, we'll talk specifically about wavelength.